AI may no longer be just a software story. It may be becoming an electricity story. For years, investors have focused almost entirely on AI models, software, chatbots, and NVIDIA GPUs. But now the industry is evolving into something much bigger: massive AI factories, gigantic data centers, entire AI campuses, and infrastructure projects so large they begin to resemble industrial buildouts more than traditional tech investments. Because AI does not need chips anymore, it needs electricity, cooling, land, networking, fiber optics, and massive data centers, power grids, and the scale may be far larger than most people even realize. Some future AI campuses may consume electricity comparable to small cities, and that is not exaggeration. And eventually, building enough electricity may become just as important as building better AI chips. AI demand is exploding globally. Companies like Microsoft, Meta, Amazon, Google, OpenAI, and XAI, among others, are racing to build more compute capacity. And this is happening at an incredible speed. AI models are becoming larger. Inference demand is growing rapidly. AI agents may eventually run continuously. And next generation AI systems require enormous amounts of computing power. This is why NVIDIA has become one of the most important companies in the world. But NVIDIA itself may also be showing investors where the next phase of AI is heading, not just towards chips, but towards infrastructure. Because the more GPUs deployed globally, the more electricity the world may need. And this is where the story starts becoming even more interesting. NVIDIA has increasingly started using the phrase AI factories. That wording matters. Factories imply massive scale, continuous production, industrial infrastructure, and enormous capital spending. And some of the projects now being discussed are absolutely massive. One example is Stargate.
Stargate, put that name down in your books because I think you're going to hear a lot about it in the future. A new American company that will invest $500 billion at least in AI infrastructure.
The data centers are actually under construction. The first of them are under construction in Texas, the Abilene location, which is our first location.
Abilene is a town on the western central plains of Texas. We kind of scratch and fight for everything good that comes our way.
I had people reaching out and they said, "Well, is the president going to come see you?" And I said, "Well, he hasn't texted me yet." So.
I'm thrilled we get to do this in the United States of America. I think this will be the most important project of this era.
Welcome to Abilene, Texas. This is the site of Project Stargate, a very mysterious, much talked about, much speculated about project that brings together OpenAI, SoftBank, Oracle. If it all comes together, building after building on this red dirt behind me will be filled with chips that'll power the AI revolution.
What we're undergoing right now is sort of the largest infrastructure build in human history. It's going to create new ways of doing business. It's going to create new ways of invention, and it's going to really drive humanity forward.
I was in the real estate business. These buildings, these are big, beautiful buildings. They're going to employ a lot of people.
Stargate is one of the largest infrastructure initiatives ever announced. Led by OpenAI alongside SoftBank and Oracle, the project discussed plans for potentially hundreds of billions of dollars of long-term AI infrastructure investment in the United States. The goal is not just software, it is AI campuses, GPU clusters, networking infrastructure, cooling systems, and massive compute deployment. OpenAI has discussed targeting roughly 10 gigawatts of AI infrastructure capacity. To put that into perspective, one large nuclear reactor is often around 1 gigawatt. Some cities operate within only a few gigawatts of electricity demand. That means future AI infrastructure projects could require power levels comparable to multiple nuclear reactors. That is an enormous amount of electricity. And this may completely reshape how investors think about AI, because suddenly AI is no longer just digital. It becomes physical infrastructure. And this may be where the next major AI bottleneck appears: power infrastructure. Because even if electricity cannot theoretically be generated, the grid itself still needs substations, still needs transformers, transmission lines, it still needs cooling infrastructure, backup systems, and years of permitting. And the electrical grid was not originally built for thousands upon thousands of AI GPUs operating continuously. And many next generation AI systems are becoming dramatically more power dense, especially with systems tied to NVIDIA Blackwell. The more electricity consumed, the more cooling is required. And AI infrastructure may increasingly operate 24 hours a day, 7 days a week. And that creates enormous strain on power systems. And that's why transformer shortages, utility constraints, and grid expansion delays are becoming increasingly important topics, because AI infrastructure growth may eventually move faster than power infrastructure expansion, and that may create a major bottleneck. And this is where the story gets interesting for investors, because the next phase of AI winners may not just be software companies. They may be the companies enabling the physical infrastructure behind AI. And there are several different categories emerging here. One company that investors are focusing on is IREN. IREN is positioning itself around large scale AI infrastructure and power capacity. And this matters because future AI campuses may require enormous amounts of electricity. The company's Sweetwater campus has discussed targeting up to 2 gigawatts of potential capacity, which is massive. And to put that into perspective, some cities operate only within a few gigawatts of electricity demand. So that means certain future AI campuses may eventually consume electricity comparable to urban infrastructure. And this is why land with access to scalable power may become strategically valuable, because eventually AI may not just compete for GPUs, it may compete for electricity access itself. And then there is cooling, Vertiv. This may become one of the most important and underrated parts of the entire AI buildout, because the more electricity AI systems consume, the more heat that they generate. And the next generation AI racks are becoming dramatically more power dense, especially with systems tied to large NVIDIA deployments. Without advanced cooling systems, future AI campuses may struggle to scale efficiently. And that is where companies like Vertiv become increasingly important. Vertiv focuses on thermal management, cooling systems, power systems, backup infrastructure, and data center infrastructure solutions. And if AI infrastructure spending continues accelerating globally, cooling may become just as important as the compute itself, because eventually you cannot scale AI without removing the heat. And then there's companies connected to electrical infrastructure itself. This includes companies like Eaton, GE Vernova, Schneider Electric, and Constellation Energy. These companies are tied to different parts of electrical systems, power management, grid infrastructure, and energy generation. And this matters because the existing grid was not originally designed for enormous AI infrastructure expansion. Future AI growth may require substations, new substations, upgraded transmission systems, transformers, backup infrastructure, and long term grid modernization. One of the most overlooked parts of this entire story may be the transformers and electrical equipment, because even if electricity theoretically be generated, delivering that electricity reliably at massive scale is a completely different challenge. And many of these infrastructure projects can take years to build. So what happens if the grid itself cannot scale fast enough? This is where the story gets even more interesting, because some companies are now exploring localized generation. And instead of relying entirely on the traditional electrical grid, future AI campuses may increasingly generate portions of their own electricity on site. That is where companies like Bloom Energy, become interesting. Bloom focuses on fuel cell based power systems and distributed generation. And this matters because AI infrastructure operators may eventually prioritize reliability, redundancy, scalability, and direct power access, especially if utility delays become major bottlenecks. And this could become one of the most important second order effects of the AI boom.
Bloom's energy servers convert fuel into electricity through an electrochemical process without combustion at the highest efficiency of any power solution available in the world today. Designed for modularity, similar to a building block, any number of our systems can be clustered together in various configurations to form solutions from hundreds of kilowatts to tens of megawatts. Solid oxide fuel cells consist of 3 parts.
And then there is nuclear. This may be one of the long term AI infrastructure themes because future AI campuses may eventually require power levels comparable to multiple nuclear reactors. That sounds extreme, but when projects like Stargate discuss roughly 10 gigawatts of AI infrastructure capacity, the scale starts becoming easier to understand. And that's why companies tied to small modular reactor technology are attracting increasing attention. And one of those companies is X Energy.
By 2050, the world's population is projected to exceed 9 billion people, and our global energy demand is set to increase by approximately 50%. When confronted with this immense growth, it becomes easy to see that the survival of our planet and continued progress of its people will require an energy solution that is both highly abundant and carbon-free. While wind, solar, and other renewables will play a valuable role in decreasing our dependence on carbon-emitting fuels, our accelerating demand for clean energy and energy security will ultimately require a source of energy that doesn't fluctuate with weather, seasons, or time of day, and can ramp up rapidly up and down to compensate for power sources that do not. Nuclear power has long represented the most viable solution to large-scale decarbonization. But from the time of its first commercial application 70 years ago, it has faced stigmas and regulatory hurdles that have inflated its cost and stalled its innovation, all despite providing around-the-clock clean energy to millions of Americans every day. Advancements in technology combined with a scale of decarbonization challenge have inspired a new wave of technologists driven to overcome the headwinds that have challenged nuclear power for decades. These innovators are developing a fourth generation of advanced nuclear reactors that are dramatically smaller than their currently operational predecessors. Developers expect that these reactors will be safer with less maintenance, last longer, and cost less to deploy.
X Energy develops advanced small modular nuclear reactors. And notably, Amazon has backed the company as part of the broader AI infrastructure and energy discussions, as they own 30% of the company. And that matters because hyperscalers are already beginning to think about long term electricity supply. Then there's Oklo, OKLO, which has drawn attention partly because of its connection to Sam Altman and OpenAI. And again, this is important less because of short term speculation and more because it shows that major AI leaders are already thinking about future energy constraints. Because eventually, building enough electricity may become one of the defining challenges of the AI era. And some companies are already exploring entirely different approaches to solving this problem. And one example is Span.
Unlikely partnership. Span, which is a startup that makes smart electrical home panels, is teaming up with NVIDIA and Pulte Group, a major U.S. home builder. Span is now making small fractional data centers, they call them nodes, that can be put on the side of residential homes. So the idea is to take advantage of unused electrical capacity on local grids, which the Span smart panels find. Now, a network of these nodes talking to each other across the country is the equivalent of a mid-sized traditional data center. So these could actually negate the need to build as many of those huge data centers. Hyperscalers and AI cloud providers just tap into the node network like a regular data center. Now, SPAN collaborated with NVIDIA using its technology in the system. SPAN claims it can install 8,000 of these units about 6 times faster and at 5 times lower cost than the construction of a typical centralized 100 megawatt data center of the same size. Now, Pulte Homes is in on the
SPAN has explored the concept of distributed AI infrastructure tied to residential homes, essentially creating smaller localized AI compute nodes instead of relying entirely on gigantic centralized campuses. The idea sounds futuristic, but it also highlights how significant future AI power demand could become. Because finding enough centralized power for enormous AI campuses may eventually become increasingly difficult. And if AI infrastructure continues scaling globally, the industry may eventually experiment with entirely new ways of distributing compute and electricity demand. The AI boom may become one of the largest infrastructure buildouts in modern history, not just because of software, but because of the physical systems required to support it. Electricity, cooling, water, land, substations, transmission infrastructure, and power generation, networking. AI may increasingly resemble a modern industrial revolution built on infrastructure and electricity. And the companies helping solve those bottlenecks could become some of the biggest winners of the next decade. Because eventually, AI may not just compete for better models, it may compete for the power itself. So if you enjoyed this video, make sure to like and subscribe. And check out the membership page at buymeacoffee.com, where we're always looking for the next 10x stock. And let me know in the comments below, which company do you think benefits the most from the AI power build out, and which company do you think the market is still overlooking? Thanks for watching, and we'll see you in the next one.